So finally, before the coffee break, we will have Jean-Baptiste Larivière from Geosat.
I would like to present you more than numbers and slides, and I would like to present you some kind of live demonstration to show you what HD map generated through the GAMS project looks like. I nevertheless have a few slides. No, you don't have the screen? Yeah, he said that. Yeah, it's this. So my name is Jean-Baptiste Larivière. I am in charge of the research and development department of Geosat, who is a French company, a French map maker, who are making maps, high precision 2D and 3D maps, using different kinds of technologies, one of which being the people that you may have seen on the streets with their rods to precisely measure location that they translate in the high precision maps. So we are doing this traditional topographic maps, and we have the goal, and I have the goal with my team, to anticipate future application and to enable the company to acquire data and to map data at a larger scale. And this is exactly the goal that we have and that we contributed to in the GAMS project, to help generate HD map for autonomous vehicle and with autonomous vehicle at a larger scale. That's why we have those two different contributions to the project, one of which is the capability to acquire the data that will help us generate the HD map, and the other one being to integrate the data that we acquired with the MMS and that is generated by our partners to create a relevant HD map, a high precision HD map, which can be loaded into the autonomous vehicle. We talked a lot about the different versions and hardware versions of the MMS, so I will go through the slides, but I would just like to insist on the fact that we talked about a lot of different data that had to be integrated in the right way to ensure that the point clouds and the data that will be analyzed to generate the HD map is accurate enough so that the final HD map is accurate and is HD map rather than some kind of SD map. So we have at hand all those different data. We have images, we have the trajectories that have been described. We have the raw point clouds that are a 3D representation and 3D measurement of the reality that can be associated with some ground control points that are locations that are precisely measured, that can be used to register the point clouds if the trajectory is not precise enough, but they can also be used to assess the final point cloud and HD map quality. And then we are computing other data thanks to this raw measurements, such as the visual odometry that is used by the partner Geonumerics, and some kind of ortho images that are this reality viewed from above, and that can be used to extract a lot of different data in the later step of the project. So that's the final version of the GAMS mobile mapping system, which is functional and had been validated in the latest campaign, and that gains from the improved robustness to GNSS reception, and which leads to improved data quality and higher precision for the final HD map. So that's what we want to generate a map which represents the reality in a way that can be used by the autonomous vehicle. But to do that, we have to go through many different steps. The first one has been to define what is the workflow to generate this HD map. And we had defined and developed many different steps. The first one being to implement or to define the data formats into which the final HD map will be saved. And we relied on two standard data formats, one of which being OpenDrive and the other one being used by virtual vehicle is the namelet format. And then to identify the various objects and information that has to be saved into the HD map, we have to make sense of the point clouds. Point clouds are 3D points, maybe with colors, in the 3D space. But this means nothing for a computer, and this means nothing for an autonomous vehicle. So we have, and we train algorithm, because we don't want to do that by hand given the scale at which we want to generate the HD map. We trained artificial intelligence models to learn what is a pole, what is a tree, what is a trunk, what are different kinds of relevant information that we want to find into the final HD map, such as, for instance, also the road markings, which are necessary to limit the road and then to define what is the lane and what are the limits onto which the vehicle can drive. And here we are talking about the road, but there are many information that we also want to encode into the HD map, such as the signs or a different kind of 3D information, such as obstacle and so on. And when we have all those different algorithms and pipelines, then we have to ensure that they can work together in an efficient enough manner to generate the final HD map. And that's why in the project we also develop a cloud architecture that takes all the different information and implements a pipeline where some information are computed in parallel, while the results of other one are taken to compute more and more precise information about the HD map. And the final step of this HD map generation is not only to be able to generate this HD map, but also to assess, to validate before sending it into the autonomous vehicle that this HD map is indeed relevant and that it is precise enough so that the control point that we took beforehand actually correspond to the real information and is at the real and the right place. So that's what we did in various iterations. That's what we planned, that's what we tested. We discussed a lot about that, so we can go briefly here. We also analyzed the results of the different iterations, and what I would want now to switch on is this, which is actually the raw data that is acquired by the LMS. So I will try to play both with the mouse and the keyboard and the microphone, which would be complicated. So here you see this point cloud. Yeah, thank you very much. You see the point cloud. So those are 3D points in space which do mean nothing for the computer. And that's why we have this first stage of classification of the points to identify what are each of these points individually. And this is very important. We are speaking about individual points. We are looking at each point to know if it is a car, if it is a building, if it is a sign, a post, and so on. And when we have this information, we can, for instance, get rid of most of the temporary information that do not have to be into the final HD map. And we can identify that some of the information is related to the vegetation, to the post, to the sign, and so on. And that's why the next step is to take this individual information and to vectorize it, which means when we have many hundreds of points to represent the pole, then we have to aggregate this information and to define where the pole is located in the most precise way possible. So this is what you see with those bounding boxes that can be applied to many different information, so that we know, and the autonomous vehicle will know where each of these different information is located. This is true for this discrete and punctual information with the bounding boxes. This is exactly the same idea with the lanes of the lanelets and the limitation of the roads that you see over there. And then you begin to understand what is and what looks like a HD map from the autonomous vehicle perspective. When you get rid of the point cloud, then you have all this vectorized information that is actually the information on which the autonomous vehicle is based to drive in the most efficient and reliable possible way. Thank you, and thank you for the microphone.
So this is static information. This is the lowest layer of the different layers of map-related data. Dynamic information, low latency dynamic data, high latency dynamic data are different stuff, completely different. If we are talking about infrastructure-related information, then we are talking about DataX2. We are talking about information that is provided by road operators, that are provided by traffic managers, etc. This is not about what we were discussing here. That's completely different topic. So I second what our presenter was saying.
Thank you.
Welcome back. This first roundtable will focus on the strategic importance of high-definition maps for connected and automated mobility and smart infrastructure. Moderating the session is Francesc Rosines from ENID, an expert in mobility innovation and dissemination. And Francesc, over to you.
Thank you. Good morning and welcome to the roundtable of HD maps as the backbone of SICAM and infrastructure management. In a context where SICAM requires high levels of environmental perception and precise localization, high-definition maps are becoming a key component. These maps not only provide an accurate georeference representations of an environment, but also enable real-time data fusion, vehicle infrastructure communication, and autonomous decision-making. Today, we will examine the critical role in the SICAM ecosystem, as well as the emerging applications in monitoring and optimizing the transport infrastructure. So let's begin the discussion with our panelists. And the first one is Jiel Martens. Jiel is working for VAX. He is a Dutch mobility consultant specialized in SICAM. He was focused on the deployment of automated transportation solutions, service design, and then development of sustainable business models. Jiel is contributing to the Ultimo project, supporting public transport operators in developing large-scale SICAM deployment, and examines the business case impact of HD mapping technologies. Jiel, VAX is working on HD maps used by Navia in the Ultimo project. What specific challenges arise when deploying these maps in urban environments with shared autonomous vehicles?
Hi, can you hear me? Perfect. Well, I think first of all, thanks for having me and having me also introduced to this project. So when it comes to mapping or using maps in urban areas for automated vehicles, I mean, I look at it from a business case perspective. So I mean, I think you're probably more aware of all the technical challenges also that we have just seen in the previous presentation. I think an issue that's or one of the main challenges in urban areas are related to the cost of mapping, I would say. Especially if we, like a couple of years ago, we did a pilot here actually at the port as well for 4 weeks with an automated vehicle. And it made me even realize more how much time, like what a tedious and manual process it is to map the entire area, and then also to get to do the data cleaning, to get rid of all the objects that are not necessarily related to the traffic. And that still remains to be an issue. I think with AI, we see that this process maybe can be done more efficient, but it still remains a time-consuming and an expensive process. Of course, what we also see is like in urban areas, the traffic situation, but also the situation of the roads, they change much more than maybe in the peri-urban or rural areas. So when we look at live updates, I'm not familiar, I'm not aware that any of the OEMs or automated vehicle providers who are offering services for automated vehicles are able to, let's say, to use these live changes and live updates. They have to make changes manually on a need basis. And I can imagine, especially if we are focusing on more dense urban areas, that these live updates would also need to be incorporated if you want to have like a seamless, smooth service. Yeah, and perhaps another thing, like at the moment, I think the market still has to kind of figure out how we are going to deal with the HD maps, because at the moment we see that the vehicle providers themselves, they actually develop also their own maps. So they maybe use like some standards, but then they still have their own proprietary layer on top of it, which you're not sharing with the others. So if we are envisioning a future in an urban area with multiple providers, they're all doing, and they keep working, let's say, in parallel and separated from each other. I think that's also just a loss of an opportunity. So that's also a challenge to overcome, to make use of certain standards that all vehicle providers can then make use of, instead of them having to reinvent the wheel themselves. And also what they often say is like they don't want to do this. It's not their core business. Like ideally they have someone else doing this for them. So I think, yeah, those things are, I would say, are the main challenges when it comes to urban areas.
Mm-hmm. So how do you think that we are going to use the HD maps in the future in Europe?
So, yeah, so I mean, we're looking at...
In particular, yeah. I am curious, what is your view about the standardization processes?
Yeah. I mean, so there are different scenarios. So I think the situation we're in at the moment is just not sustainable, of not having these standardizations and companies just doing and developing their own maps. I think at the moment we also haven't found the incentive for, let's say, a company like Mobileye, for example, to say, well, why don't you open up part of your IP and your maps to others? So what I could imagine as a workable situation, and that's kind of what we're working on in the Ultimo project as well, where we're deploying vehicles in Oslo, Germany, and in Geneva, is to work on some like a hybrid version. So where maybe the first two basic layers of the map are standardized, and then sure, like for the last part, the OEMs can add their own, let's say, their own proprietary layer to it to connect it with the vehicle. But I think if we leave it up to the companies to arrange this and to come with these standards, I don't think we're going to get there anytime soon. And therefore, I think as in Europe, we can also learn from what is happening elsewhere. So, for example, in Japan, they basically regard the HD maps not necessarily as a commercial asset, but they actually regard it more as a common commodity. So the Japanese government, they set up this collaboration with all the known manufacturers from Japan to basically develop this national map that everyone would then make use of. And I think that's the closest we can get to some common standards in HD maps. So it's very exciting to see how that is developing and what we can learn from it in Europe. And in Korea, they are doing something similar, but then maybe less. It's more of a one-on-one collaboration between Naver, this technology company, and the government itself. But the final outcome or the objective is the same: to come up with a national layer and a national map that can at least provide the first few layers and create standardization in there. Yeah, so I think that's I would imagine as Europe that we are going towards a model like we have in Japan or Korea at the moment.
Do you think that there is any kind of a scenario where HD maps is not useful for CCAM or for autonomous vehicles?
Yeah, I mean, useful, and I mean, I think HD maps can of course always be useful, but I think that there is a scenario also to consider where we won't use HD maps for automated vehicles. And we see that, for example, with Wave. I mean, it's all very early stage, but we have Wave. There's company from the UK that is one of the, let's say, more advanced companies in Europe. Not that difficult because in Europe we're not so advanced when it comes to automated vehicles, but still. And they claim, let's say, to rely on not on any HD maps, but they rely on the intelligence of the instant computing power and AI intelligence. Sorry about that. So whether that holds any, let's say, truth or any ground in the future, that I don't know. But I think there is a scenario to consider where we won't have to rely on HD maps for automated vehicles.
Thank you very much. So we will go for the next panelist, which is Marc Facerias from IDIADA. Marc is an engineer of A+ IDIADA. He works on advanced systems for autonomous vehicles with focus on positioning and navigation technologies. Previously, he completed a PhD in the University of Manchester, where his research focused on localization in GNSS-denied environments using sensor fusion techniques for autonomous systems. Marc, you are here representing several things, but mainly the Synergies project. Okay. Synergies has been running for a year. What have you already achieved in the first year, and what is the plan for the next 2 years?
So, well, thank you for inviting me here. First of all, let me give some context about Synergies. Basically, the Synergies project, what it wants to do is to create a data space where driving scenarios are collected, and so that people can just go there and get data from that space to train and validate their CCCAM algorithms. And just another parenthesis, a driving scenario is information about a maneuver that has both the dynamic part and the static part. On the static half, it's pretty much what we saw here today, just what environment is being traversed, and on the dynamic half, we have all the information about moving vehicles, moving pedestrians, or things that change during time, but that are important from this driving scenario. The ultimate goal of Synergies is to give the data so that other European projects or other private initiatives can, as I said, validate and develop their own CCAM algorithms in a solid and informed way. Well, as you mentioned, right now we are at the end of the first year of the project, and what we have done at this point is to have an alpha version of this data space, which will connect tools to deal with these driving scenarios, other databases, and will also include proprietary data collected during the experiments. And then, as a plan for this next 2 years, what we want to do is to start populating this data space, both with our own data and with data from other driving scenario databases that are currently available to the public.
And how do you envision the relationship between Synergies and other CCAM initiatives? Are you building internal methodologies or lessons learned?
So, Synergies has a special focus on security, as the previous project that we mostly learned on is Sunrise, which developed a safety assurance framework for the CCCAM projects to validate their algorithms. Using the information learned during development of these protocols, we started building the database that will, in the future, feed all the algorithms developed in Sunrise so that this validation can be done. Then, in terms of collaboration, we have 2 potential collaboration strategies. On the one side, we want other projects and companies to use the information that Synergies is gathering. So we are kind of looking for future users of this database. And then on the other side, we want to collaborate collecting more data. So the project is always looking for potential partners that can help populate this driving scenario database and contribute to both tools to actually extract and deal with the scenario data, and also the data itself.
What's the role of the AT maps in the synergy project?
Well, as I mentioned before, static information about roads, it's something really, really important when dealing with scenarios. Theoretically, we could assume that all that information can be derived from sensors in a vehicle or in the platform that we use to collect that data. But as we have seen today, that's not a trivial task. It's quite costly to derive accurate maps only from vehicle information, and this would limit a lot the sources of information that we can use to populate the data set. On another hand, if we assume that there are HD maps available, we can offload a lot the task of describing the environment, as we have a clear knowledge of what's going on our roads, where are the lanes, where are the traffic signs, and what considerations can impact our driving scenarios. And nevertheless, it's important to remark that acquiring HD maps is not a trivial task either. So I'd say that they are a really powerful source of information, but looking forward to the future, it's more a matter of how we can use available information in each particular case, rather than relying too much on either only maps or either only sensor information. Yeah. So I think that the balance is the key in this type of project.
It's the difficult thing, the right balance.
Yeah. Well, I hope that by the end of the project, we will be able to develop a tool set so that we will be closer to this balance as a community here in the European ecosystem.
Thank you, Mike. So let's go to the next panelist. This is David Quesada from ENIDE. David is a computer engineer. He's a technical director at ENIDE, working in several technical aspects in CCAM projects and other mobility-related ones. David participates specifically in the Podium project in a CCAM shuttle on-demand case. David, can you explain all the specific use case that ENIDE is leading within this Podium project? What makes this different to other similar ones?
Okay. Hello, everyone. First of all, thank you for being here, and thanks for inviting me to talk. Podium is a Horizon Europe project that is trying to build an architecture for a robust digital, physical and digital infrastructure with the focus in cooperative and collaborative and automated mobility. Taking safety and enabling intelligent traffic management strategies on real time during the operation. So the architecture is based on real-time data exchange for CCAM with MEX, with edge-centric architecture, multi-access edge computing, dynamic ICT messaging with several formats, several combinations, or a combination of several means of communication, radio frequency, and so on. And also there are several use cases demonstrating all this architecture. In several cases or in several scenarios like urban, highway, and channels and so. And we as ENIDE, we are mainly in what we call use case 3, that is about building a scenario, a cross-border scenario, trying to maintain a service, sophisticated service, CCAM service on the moment that you need to make the change from one country to the other. And this service basically is a shuttle, an autonomous shuttle that is going from one side to the other of the border. We choose the Spain-France border, especially initially was the plan is to link with this service Le Boulou and La Junquera, that are two small villages on each side of the border. It's very interesting because they are very close, like 20 kilometers far from each other. But at the same time, they are close, so they have a lot of activities together, and they try to build activities together. But they belong to totally different administrative structures. So it means that a service like this, like a dynamic shuttle service, for them could be very used in order to change from car, that is the personal vehicle, that is what they use right now for make anything on the other side. Instead of this, using an autonomous shuttle and try to substitute personal vehicle with this. In this case, in addition to the shuttle, autonomous shuttle that is from Mila, there are a number of companies providing additional infrastructure service, digital infrastructure service, like IDIADA or like E2CAT. They are trying to build this additional layer for supporting the service during the cross-border and the handover between one operator to the other. So in this sense, it's a very complex scenario because the service has to be has to work smoothly, and at the same time there is a moment when there is a border that there could be issues with the communication. In this scenario, NIDE, what is providing is a passenger app that is managing the expertise or the experience from the passenger interacting with the shuttle, also providing the shuttle management when the shuttle starts moving and so on, and also providing during the travel, during the trip, information to the passenger regarding the trip.
In fact, Podium focus heavily in real-time data exchange for SICAM systems. What technical or operational innovations have been introduced to make this possible?
Okay, the architecture, I think it's very similar to other similar projects in this area about SICAM and about trying to build physical and digital infrastructure. Here the focus is on MECs, in multi-access edge computing, so trying to build or trying to deliver most of the computation of the services very close to the vehicles moving by the highway. In this sense, we are using several communication technologies like Wi-Fi, using roadside units, but also cellular V2X communication, and in order to have different ways to communicate with the vehicles. And also we are using different subsets of CITS message in order to have not only the communication, the direct communication with some of the vehicles, but also to organize the overall traffic, trying to deploy dynamic traffic management strategies in order to cope with some specific questions or events in the highway, like lane change or things like a car that is broken, or to basically to reduce the speed in several or in specific scenarios, and organize the communication between all the vehicles that are there.
There is also a link between Podium and GAMS projects. How these two projects complement each other, specifically in areas like the data governance and digital infrastructure? Okay.
I think they are very complementary in the sense that GAMS is more focused on the HD maps building, while the Podium is more focused, or in this aspect is more focused on the local dynamic mapping. I mean, dynamic maps made with the current information on the traffic situation, traffic jams, vehicles that are stopped, or any interruption in the service. So in this way, I think there was a question on the previous session about this. This is a complementary view. You have let's say the current situation, or let's say physical situation of the infrastructure, the highway, and then you have on top the current situation about whatever is happening there. What is the speed average there? If there are any special incidents between, for example, if there are specific tracks, because in the highway, especially in the cross-border, there are days that there are heavy traffic crossing the border, and mainly is about big trucks. So all this information is complemented with the high-definition map. So at you have a full picture of the two situations, let's say the more infrastructure, physical infrastructure, and the digital view. Also, in Podium, we are working to provide some digital twins so they can experiment on the decisions based on these situations that are happening on the road, and taking decisions or analyzing if the decisions we're applying certain traffic strategies are good opportunity or not to solve any issue they can have.
Okay, thank you very much. Very interesting. So, now going to Selim Solmaz from Virtual Vehicle. Selim is head of the Control System Group at Virtual Vehicle Research in Austria, where he leads research on automated mobility and autonomous robotic systems. He holds a PhD in electronics engineering from the National University of Ireland, and previously degrees in aerospace and aeronautics. Before joining Virtual Vehicle in 2018, he was lecturer and researcher leader in Turkey and Northern Cyprus. And other things that I have to show because the video is very long. Okay. Selim, Virtual Vehicle is offering autonomous vehicles for piloting the GAMS project. What are the most important learnings from this pilot test so far?
Thank you very much, Francesc, for the nice introduction, and I would like to thank all the organizers for the invitation to participate here. So, regarding the question, I would like to refer back to my previous presentation. Actually, in the last slide, I mentioned the bottom line. So, I think automated mapping for the purpose of automated driving is possible. And we have demonstrated this nicely in the GAMS project. And I have to say that the HD map generated by Jean-Baptiste and his team was excellent. So it was almost perfect that we plugged it in our system, and it was usable directly. So if we can generalize this, standardize this, I think we have a way to go. And this may be actually the way to go ahead for bridging the ODD gaps. To help with the localization of the automated driving system and have a more reliable localization, which is the essential part of automated driving software.
GAMS aims to strengthen predictive and cooperative mobility. How does your technology support this ambition, particularly in edge case or complex traffic scenarios?
Yes. Actually, complex traffic scenarios was not the main focus of what we did in GAMS project. Actually, this is something we already started thinking about in a previous project that we did together. So in Inframix, if you remember, David, there we started looking into interaction of automated driving systems at different autonomy levels with the complex scenarios. And we tested this in simulation back in Inframix project. But in GAMS, actually, so what we have tested was different than in Inframix. So in GAMS, we have tested something in real life, but the software that we used for the automated driving is also different as what we have tested before. So the software that we use here, based on the AutoWare open source automated driving framework, is possible to also simulate, right? So what we use in the vehicle can also be directly represented in simulation. So it's more or less a digital twin. And in edge cases, which we would like to test, is not necessary to test only in real life. So we can actually represent these scenarios in simulation and test the behavior and safety of the automated driving system in simulation. So, for example, referring to the Synergies project, where one of the aims is to validation and verification, utilizing a scenario database, among others, of course, it's not the only aim, but so the digital twin can be also plugged in the solution of the Synergies project, where depending on the driving capabilities or driving autonomy level, one can use these edge scenarios as part of the validation and verification framework, and it's possible to do with the solution we developed in this context.
In your previous presentation, you discussed about mentioned both Esrium and SRCOMD projects, and how a project like GAMS is in the production SD maps and facilitating it, calling back in road condition monitoring.
Could you rephrase the question? I didn't
Yeah, mainly is how the GAMS results could contribute to the SRCOMD or...
Yes, yeah, definitely. So in Esrium project I mentioned in my slides, in Esrium the focus was road wear map, right? I think this is an idea which is interesting to incorporate as part of the automated driving system and solution, where I think a map layer based on road wear map can be used as a factor to make decisions. Like, so if there's a damaged road section, you can automatically avoid this section by the system, or it can be also communicated by the infrastructure measures, some sort of V2X or ITSG5 communication capability can provide safety messages to the oncoming traffic and connected automated vehicle to make it avoid this, let's say, dangerous road section. So this is a reality. And actually in GAMS, automated mapping of the road was the focus. And I think a mass-produced HD map to be utilized by automated traffic is the main content here, and I think it's quite realistic as we have implemented in the GAMS context, but it can be extended, of course, to include additional information like road wear information, instantaneous traffic hazards, like if there's a stopped vehicle on one lane from broken down vehicle. So you can already communicate this to the oncoming traffic, which knows this up ahead, and reacts to it to prevent any last-minute decisions. Because with traditional approach, automated driving system uses perception sensors. As soon as they detect an object and classifies it as a hazard and then reacts accordingly. But this may be too late to initiate such evasive maneuvers, right? If we know this up ahead using an E-horizon concept, then we can actually adjust our driving behavior accordingly before we come to this situation. So in the various projects, we are looking into different aspects of it, and I think we need a unification of all these concepts. Yeah.
I have to say that in MODI project, they are unifying several aspects previously developed in other projects with just one chain, yes, demonstrating all the previous results.
Yes.
Thank you, Sherry.
Thank you very much.
So let's go for Laia Pagès from CARNET. Laia Pagès is the director at CARNET, that is the Future Mobility Research Center at UPC, and co-founder of Baire Logistics, a tech startup on autonomous delivery robots. She has been involved in Logismile and Botnet in Catalonia and Hungary, Germany, different pilots. Okay, let me discuss with you out of the technical box. Because we are more focused on technical aspects, but maybe we have to try to guess what will happen with what kinds of new professional profiles will be required in the near future.
First of all, thank you for the invitation. Yes, I'm at CARNET, and we are involved in a lot of CCAM projects. Actually, I saw here the cultural roads. We are there. We are in CERTEN as well, and some of the projects that you mentioned, we have been somehow involved as well in Julia, etc. And since I am the only woman, I'm going to talk about something different. No, let's do it like that. Because this mapping issues reminds me of my PhD area, and I'm a civil engineer, but with a software background, and my PhD was dealing with simulation of transportation systems that at that time were not autonomous, but we were simulating them. So we were simulating how people behaved, all these lane-changing algorithms, these car-following things that you are trying to do now in a world, no? And since Carnet is at UPC, and I see the parallelism between what I was trying to do and what is now going to the streets, which was not the objective at that time, and we are here to think, no? Maybe one of the things that we have changed from 20 years ago is the computational capabilities. We are talking about something that we were not able to do, really. We had a lot of computational capabilities. I'm talking in California, connected to PATH and what is DGT here in Spain with a high profile at that time was incredible. But we were able to, to simulate 9-10 nodes, not more. Today we are talking about digital twins of Barcelona and the metropolitan area, and we are doing it at Carnet without having any connection at all, going there and begging for data. That's what we do. This is one of the changes. And the other change, I think, because coding has not changed that much, I think that really maps have changed a lot. And what I think, and maybe I like to be a little bit different, but I already said it at the beginning, I am in a room with a lot of men, I'm a woman, so that's already a difference. But for automatic driving, this parallelism between what we need in terms of sensors and where I am and what is next to me and what is in the network, and I try to optimize, I try to route and try to... I don't think that we have to do a real equilibrium. We have to deal with the needs of each of the situations. No? Maybe for something that is very direct, I do need these sensors and all these fusion algorithms and everything. And maybe for other issues that I want to optimize, road safety, sustainability issues, blah, 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 I need to go to HMD maps that I think that will survive in the future, but for maybe other needs. And this is the parallelism that we need to do. And I wanted to talk about the needs of professionals that have to evolve with that, because I was not taught in these issues. No? And I have tried to learn all these things, and I guess that you as well, because for the age group that we are in this room, it's not something that we have been taught in the rooms or in the universities or in high school. No? And this evolving of the needs of the future, as university, we need to adapt ourselves and see if HTTP maps are going to be used, and then train people so that they can do it, and all these problems that you have to deal with last-minute things that are very expensive and very difficult, no? Because everything is very automated, but at the end you need someone that validates and blah, blah, blah. And maybe you can do it with robots as GAMS, but sometimes it's not that automatic. And then we need to train this, and we need to evolve as a society so that we can train these people. And we are trying to do that at Carnet with some topics, among them these automated algorithms and things that new generations need, and might be there some time, but they are not a need now. So.
Okay, so regarding the education of these new profiles, what is the biggest changes and challenges we can guess, and how to map it, and who has to map it?
Well, the automotive industry has a big challenge. I don't want to talk about problems, because the people that are working in the automotive sector are not very digital, no? And we see it every day with our founding partners that are mostly automotive, and the profiles that are in these rooms give services to them. No, it's the job of a public authority, or it's the OEM and the car that needs to produce their maps and do it themselves. Or we talked about layers that are not standards, but they are producing it themselves, and you said no, it should be done by someone else. Well, we'll see what is going to happen in the future. We as Carnet have been producing upskilling and reskilling programs to go into this digitalization with specific profiles, I don't know, autonomous vehicle, electrical vehicle, and other issues that were needs of the companies, and these studies have been certified by the government of Spain, and we try to move towards these objectives.
I guess that these profiles has to be transversal with several studies.
Yeah, this is the question, no? If they need to know everything, or if you need to change the profiles that you have, which is very complicated in some cases, or you need to give more skills to people that are already there. I guess that it's a mix of everything, and this is the equilibrium that needs to be found. Yes.
The devil is in the details. Okay, thank you very much.
Thank you to you.
Thank you to all of you to be concise. We recover a bit of time, and maybe we have a bit of time for some questions from the audience.
Well, maps have been around for many years, as you know. And actually, if I consider myself a member of the map-making community, because I am also a cartographer, I have to say that we are competing against another community to see which is the oldest profession in the world. We claim that we were first than the other group that you could imagine. Now, so maps have been evolving. The Eskimos, the Inuit, have their very accurate maps, but they have them in their mind, so they don't put it in, but they have maps. In the Middle Ages, we had maps. In the beginning of the Enlightenment time, we had maps, and it was a matter of being a traitor, being a fish, for instance, at that time. So we'll keep on having maps for many more reasons. But the question is, up to now, maps were produced by public bodies, by the cities, with the taxpayers' money, and they provided to the community and depends on the studies of the institutes, but now the stories so something new and much called regional I have my opinion, but I think that this is what we want from our society. No, if you ask an American, maybe the answer is very different than if you ask an European that tend to give our states more roles than Americans. There should be
institution that should be central somehow and should be the one producing these maps. Because if these maps are produced with commercial, let's say, objectives, then we are somehow prostituting the system, no? And I don't want to enter into the oldest role of the world, no? But who brings it to the market and commercializes these maps? This is the question, and this is a societal question that depends on the role of the government that you want for your society. The answer is very, very different. I want to add a conversation that I had not a long time ago with someone that works at WIMO, that is working at Research WIMO. So they are not in operational, they are dealing with, actually they have been now involved in prediction. No? Everyone is prediction, artificial intelligence, if you can predict and for them this answer is very, very clear. The maps is their maps and they don't want to share it. And there are commercial reasons and they are moving forward and I don't know, because of that or because of other things, they have cars that are running autonomously there and not here. So, but this is a reality. So it's just the two answers. Thank you.
I like to believe that I'm part of the research community here in Europe, and we all know that right now having access to accurate, reliable maps is behind a huge paywall, and by giving more power to the public organizations to handle these maps and some sort of be the judge that decides more or less how do we do them, how we distribute them, and how available are to the public, we will be creating a research environment where individuals, universities, and other entities would be able to use a really powerful tool, which is the one that we find in HD maps, to skyrocket the development and explore algorithms that maybe right now they wouldn't even think about because they cannot pay the cost of getting to those maps. So now that we are starting to, well, as we saw, to generate in a more or less autonomous way these maps in a reliable way, in my opinion, it's the time to push as a community, as a research community, so that these maps and resources are as open as possible to individuals that would like to contribute to the European research and the European and Europe as an agent in the global research environment. And I think that if we can give this data, maybe not for free, but under reasonable circumstances, we would be giving a lot of power and strength to our local universities and local companies to be able to skyrocket their research and probably compete in a stronger position with the rest of the world. That more or less it's something quite important in the current context of European research. So at least from my PhD researcher position, I think that that's quite an important thing to democratize the access to this information, or at least standardize it so that maybe we don't have access to the best map out there, but at least we have access to some sort of non-sample or not as accurate version, but we have a guarantee that we are working with cutting edge, with state-of-the-art specifications of these HD maps. And yeah, I think it's crucial for the next years if you let me give my opinion. So that's all on my behalf. No, I like the vision that you described, and I think it corresponds to a large extent to this vision that Japan has, and they show like no, you do need like a public body or some authority that takes the lead, because as you mentioned, like Waymo does not want to share, but if you ask any European OEM as well, like or the ones active in Europe, like Mobileye for example, or the new Chinese ones, but also
add a stack, if you ask them, they also don't want to share because it's part of their IP. So, and there's no incentive for them to share it at the moment. And and therefore I think, yeah, you would need this public body involvement to get to this, standardization. And also it would just increase transparency because at the moment, even the PTOs who are contracting the companies, like Mobileye, for example, there's no insight in how they use the maps, which factors they take into account or not. So it's also very difficult as a public authority to then steer towards, like you said, like there's maybe certain needs, maybe certain safety needs in certain zones where you would like to have more influence as a public body, but then as the whole mapping is a black box of the company, as they don't want to share, it's very difficult to have any influence over it, which I think is probably not a very sustainable model for if we are going to move towards large-scale deployment at some point.
Maybe I can also say a few words. So I think the initiative is good, so I would fully support this, but I think we should start from the standardization of the definition and content of the HD map, yeah? Because it tends to be quite subjective. So as soon as we can formalize this, I think this can be also a driving factor in expanding automated driving systems and CCAM systems in Europe. And this can be a benefit, I would say. Yeah, I think there's a good reason to think about this.
Thank you, Andres. Interesting reflection. So, time is gone. Thank you very much for the panelists to participate, and we will go next to the next roundtable. I guess that if you have any additional question or comment, maybe after the event you can do it to the panelists. Thank you very much.
Thank you for all the speakers from the first roundtable. So now we move to our second panel, exploring how geospatial intelligence and data-driven tools are accelerating innovation in mobility and infrastructure. And moderating this session is Francisco Santa-Remidia from ITEC, a specialist in geospatial R&D and innovation ecosystems.
Thank you so much for your introduction. Thanks. Well, good morning again. Welcome to this second round table. The name is Driving Innovation with Geospatial Intelligence. This is a nice name for the round table. I must say that now I am understanding perfectly the name of the project GAMS, Robots Mapping for Robots, because in Google, going to my first question, in Google, the car which is mapping the roads are human driver. And Enrique clarified to me that in GAMS we will have autonomous driving for this action, for mapping the maps. So the name is perfect, Robots Mapping for Robots. This means that we will have 24 hours, 7 days in a week to map the roads. Nice, brilliant idea. Thanks for your clarification during the break. I will let the panelists to introduce themselves about the background and the projects. I will start. I am Francisco Santa-Remidia. I am naval engineer. I have a PhD in transport system. I come from the company ITEC, which is based in Valencia. It's a private research center established as a small and medium enterprise. And I am here also in representation of the project, Horizon Europe project FITER, which is analyzing the vulnerabilities that all these technological advances are generating. Okay, some people will remain behind with all these innovations. For example, taxi drivers, drivers of trucks, and so on. Okay, so in FITER we are analyzing vulnerable groups coming from the digital transition. Not only from autonomous vehicles, or autonomous driving, but also from electrical cars, for example. We have another vulnerable groups, which are people who cannot afford an electrical car at this moment, okay? So this is a social perspective that we don't need to lose, sorry, okay? Now we are in a technological session. Let's move to the technological part, but please keep in mind that there is a social part that we need to address, and this is the aim of the project FITER-EU, okay? Given said this, I let the panelists to introduce yourself and your projects in 1 minute, if you agree. And please go ahead. We can start from left to right, and that's it. Andras, please go ahead.
Thank you so much. So my name is Andras Czepinski. I am the founder and CEO of Motere non-profit Ltd based in Hungary. It's a mobility technology research company that we created last year, and now we are a happy consortium member of SRCOMD, which is the project, the follow-up project of ESRIUM, which we had great interaction. And by the way, I was also external member of the advisory board of GAMS back in time. So SRCOMD is just a follow-up of ESRIUM, and we are looking at how to raise the TRL level of the concept that we developed together with the ESRIUM. And I think, as you could see, I am more a standardization guy, so I will talk about standards, GIS standards, map standards, and all related data, dynamic and static data, which are needed for CCAM. So that's my specialty, and this is I'm working in more than 20 years now.
Perfect. Thanks so much. Daria, please, who are you?
Yes, so thank you from my side as well for having us here. So my name is Daria Perun. I'm from ASFINAG. We are the Austrian road operator for the whole highway network. And I'm also the part of the consortium with the project SRCOMD, and I'm a co-joint project management manager from ASFINAG side. And within the ASFINAG, I focus more on the concepts of digital twins and how can we put them into life. But since our last goal is to provide the real-time data to all of our customers and as well as support automated driving within our highway network in the future.
Perfect. Thanks so much. Jose, please go ahead.
I will start as Andras and Daria, thanking the GAMS project and Enide and all the organizers for inviting us today here. So my name is Jose Solis, and I'm currently Research and Innovation Director within CEMOSA. CEMOSA is a civil engineering and quality control company based in the south of Spain. We tend to say that we do everything around construction, but construction itself. So we are a civil engineering services provider. And within the R&D department, let's say we work on developing new solutions and tools for the company and for our technical areas. And within this work, we coordinate and collaborate in different projects. One of them is shown in the slide is the Moveo project, in which we are in a continuous development process of towards the development of digital twins for transport infrastructure. And in this case, we have a focus on multimodality, mobility services, and inclusiveness. So slightly related to what you presented. So thank you very much.
Thanks so much. Jose, Eulalia, please. Go ahead.
Hi. First of all, I would like to thank the organizers of the event for inviting me here to this event. It's a very interesting event, very interesting morning, and different from the rest of the week being on the office just typing and typing. So it's nice to go out for some hours. I'm here on behalf of CTTC and on the project 5G Routes. 5G Routes is a CCAM project on that it's devoted to connectivity on the border, on the northern countries, but also not just for the connectivity, but also for our expertise on mapping and on geodesy and geomatics. So it's a pleasure to be here and to contribute as much as we can to this panel.
Perfect, thanks. And you are totally right. We are now teleworking too much, and we need to go out from time to time to this kind of events. Alex, please go ahead.
Thank you very much. I would like to start to thanking the organizers and the GAMS project for inviting us. I'm here on behalf of the company that pays me, that is Eurecat. I work there as a research scientist. My background is a PhD in physics, which is a bit weird. We mainly work on mobility and computational social science. That means the intersection between mobility and society, mobility and inclusiveness, a bit in line of what he said before. And that's more or less it. Yes, the most related project we are working on related to GAMS is Diversified CCAM. This is not a super technological, super fancy project with maps and colors and that. It's more about when CCM services are deployed, who will be affected, who will use them, can we make people that are more deprived use these services. So we are a bit of a blind spot, let's say, because these services are not here yet, but it's trying to understand how to frame these services so that everybody wants to use them and everybody gets the benefit of using them.
Yeah, thanks, Alex. I think that Diversify is the SICAM version of FITR. So we will have a nice discussion later.
Yes, also I think we are sister project of Cultural Roads.
Okay. And ERAS, I think this is another, ERAS is another project related with this kind of inequalities that SICAM is generating. Very nice. Okay, so I will change the dynamic of questions from the previous roundtable. Instead of asking each of you if you agree, all the three questions per each one, I will change to make it more dynamic, one question to each one, okay? So I will start from you, Andras. ESERCOM is your project now, okay? And you are expert in standardization. How this project is contributing to this standardization, and why is this important? What will be the impact of this standardization in SICAM in the next future, please?
Okay, so the goal of ESERCOM-D in the standardization is multifold. Very much we were looking at as a heritage from ESRIUM, looking for road damage data, a road damage map layer that is defined. We created a full value chain where we perceive, we aggregate, we treat, and we deliver this information to the vehicles. So it was a gap in the standards to provide this kind of information. There was no data or data attributes allocated to this kind of information. So that was a gap analysis which led to this standardization work that needs to be delivered into different standards like DATEX2, like TPAC2, like the CITS, DENAM, and IVI. So there are a number of dynamic data standards has to be expanded to cover this kind of information. In addition to that, it is very important to know that this dynamic information has to be matched to the static layers. And for that, we have to have very precise information. And how to match that precise information? We need a location referencing method which provides this accuracy and provides this information, very accurate information we have, to be matched on a HAD map, a highly automated driving map, matched accuracy
to exactly the location where it is in the real world. So this is where we provide this information.
But do you think that we are in the right way now? Because I am a bit pessimistic from your arguments before. I am not sure that we will achieve this in the short term. How do you see this?
We have a number of challenges. We have a number of challenges of interoperability, of static maps. That's a different story. We have challenges in the dynamic layers. That's also a different story. And we have to have this complete holistic view of static and dynamic to put together. And we have a very detailed ecosystem that we worked out. We are working on how to harmonize and synchronize all these different standards to create a smooth HAD or CCAM standards ecosystem that helps the deployment of CCAM technologies.
And how long? Can you give me some time? 5 years, 10 years, 50 years, 100 years?
We can do it even today, but we improve it. It's like the Kaizen approach of Toyota. We always improve, and we do it, we test it. We have high drive project, we tested it. We call them, in a high drive project, we call them technology enablers, how CCAM can help to defragment the operational design domains. And these technologies, maps, dynamic data, etc., will help to defragment and make smoother operational design domain to achieve level 4 automation.
Okay, so it will depend, the time will depend on our performance and our willing to do the things.
Exactly.
Perfect, perfect. Daria, ASFINAG is your entity, right? It's a road operator, and how are you using these digital twins and the high definition maps in your company as road operator? How are you using this technology?
Yeah, so thank you for your question. So as I already mentioned in the short introduction, our goal is to provide the most quality data to our customers and to support the automated driving. And that's why we see that digital twins is a good solution here, since they make it possible to combine different layers of data. And currently we're working on such digital shadow solution, which has the base of the HD map, which has already been mentioned a lot today. And maybe this is also the answer to your question before, is it enough? It's from our perspective, I'm also seconding the Andreas here, it's not enough. So the basis forms, this forms the basis for the further layers, such as real-time corrections, road weather, and the traffic regulation. Mm-hmm. And the main idea behind this is that all the data that goes into the digital shadow is improved within this layered approach that it provides.
Okay, nice. Thanks so much for your explanation. And Jose, Zenbox is a digital platform, right? Which is generated in the Omicron project. How this platform, Zenbox, has been evolving along the project, and what is the current status of this platform now, and can be used by the company of Daria tomorrow?
Mm-hmm. Yeah, thank you for the question. Well, first of all, as I stated in my background, let's say we are coming from a slightly different perspective. So we are a company providing services to the infrastructure itself. Let's say we are looking at the problem from two parallel sides. So we provide a safe infrastructure in which then CCAM, etc., can evolve, or normal driving. So, well, this is, I believe, important to highlight. In this context, we have been working on digitization of transport infrastructure for some years now, and we have worked in different European, private and national projects in order to execute this and to generate new services for companies as FINAG, in order to improve services, reduce costs, etc. In this context, we started this Zenbox Infra platform, which is a digital twin for infrastructure, civil infrastructure asset management within this project that you mentioned, Omicron. Now we are continuing in the one shown here, Moveo. And let's say we started with BIM in 2010 within our company, and we have been evolving from the concept of a BIM GIS, of a BIM representation of roads to the concept of a BIM GIS environment in 2019, up to the state at which we are now, in which we have a digital twin platform providing capabilities for visualization, for prediction, and for simulation of road infrastructure state, or in general, transport infrastructure state. And within these years, we have seen an evolution on different areas. We have seen the rise of AI. We have seen, it was mentioned earlier, the rise or the increasing rapidness in computation. So this has been key in order to have accurate digital twin models. And well, we have interacted with GAMS in some events, and this is why we're happy to be here. And we have exchanged some ideas and stuff. And at this point, let's say we are at the stage of deployment. Public and private organizations are at the point in which we can include this into real life operation in order to improve costs, also services, and also introduce the concept of sustainability in our infrastructure maintenance. And we are working on it. And well, we have pilots within R&D projects, but we are actually working on this jump to real-life commercial scenario.
Jose, have you estimated the reduction of cost? Because you have mentioned the cost two times to convince Daria to purchase your digital platform or to implement your digital platform. How much she will reduce the cost? And another aspect, the environmental impact. Have you estimated how you will improve the environmental impacts by using this digital platform?
Well, it is a very good question.
I know.
and it is a very broad one. So let's say we have worked in specific use cases on the application of digital twins. For instance, we have done use case in the A1 in Italy from Florence to Bologna. And in there we have focused on two specific assets. Roads have many more. We have focused on bridges, in particular one bridge, and on the pavement state. Within these two use cases, within the project, and I can provide more information on the Omicron project, we have shown a reduction in life cycle maintenance costs of up to 20%. But yeah, I don't want to say this is for every single asset. We have specific cases in which we have tested an improvement, and we believe that this can be the case. Same can be with sustainability, with emissions, but on that side, I don't have the specific numbers within the project.
Okay. Is sufficiently convincing, Daria? Will we buy the? Okay, perfect. Okay, Eulalia, let's go to you. You are expert in communication technologies. You explained it to me that there are some challenges in communication technologies on borders. This is a real challenge that we have. And on the other hand, the real-time in CCAM applications we are watching during these sessions is very important. How these communication technologies can enhance these real-time CCAM applications?
Yeah, I will start, if you allow me, to answer the question by doing another question. Okay?
Perfect.
So the other question is why we are here, why we are doing this. For some people, this is an economical issue, to save money or to earn money. Okay, for others, it's just a simple question of commodity. I do not want to drive. Okay, and for others, in which I include myself in, is for a safety thing. Okay, we want to do things in an automatic way in order to increase the safety. But we are trying to substitute an extremely complex machine as a human being by a technology. It cannot be done. There's not a single technology in the world that can substitute human beings. Okay, we have a driver that it's a human with a brain and with a lot of sensors within ourselves. Okay, and we need to substitute that for some technologies. So we will have artificial intelligence that will allow us to take some decisions, to do some recognition. We will have these maps, but it's all background knowledge of our environment. They are crucial, okay? Sometimes we can go from a point A to a point B without knowing anything, but it's better if you have a map and if you know your path. And of course, we have our sensors that allow us to know if there's any inference on our path. There's a rock, there's a pedestrian, someone, okay? With the technology, what we want to do is to go beyond our sensors and maybe to see the pedestrian that we cannot see that it's crossing on the other road, and we are going to turn around and it's a pedestrian in the middle of the road, or that car that has some strategic maneuver. So we have a neural, a nervous sensors within us that communicates our sensors with our brains. Communications is exactly that point. It's bringing all the information from the sensors inside the car and outside the car to the brain that it's going to take the decisions at that exact point in order to decide if to brake or to accelerate. And it has to be reliable and it has to be fast. And since it's technology, we need low latencies, a lot of things, but the communication would bring it's all the information to be on the place that it should be in order to take the correct decision and to save life at the end.
Yeah. You have mentioned the two key points for our implementation of a CCAM solution, which are the business model, you mentioned it, and safety. These are the two key aspects to implement a CCAM solution. This is true, but this is another point that is true, is also true, is that at this point, you know that the communication technology and CCAM solutions are, from a safety perspective, in a low level that the human safety. In United States, we were commenting this during the break. In United States, they are facing a lot of problems with safety, with a lot of accidents, incidents, etc. So, do you think that we will be able to break this barrier and we will improve the human neural networks with your communication systems?
I'm not sure if with technology we are going to improve a human being, because it's very complex and millions of years of development and improvement.
Exactly.
Okay.
So how long? Again, 10 years, 100?
I cannot bet on that, but for sure with the new quantum technologies that it's going to come and the new processors and the new standards on communication, maybe it's not going to improve a human neural system, okay, but it is going to improve quite a lot of what we are having right now. Yeah.
Okay, perfect. Thanks so much. Let's go to Alex from Eurecat. Data science. This is your expertise. What is the role of data in CCAM solutions? I think that this is obvious.
Yes.
More or less. How this data can take into account the diversity of local context? This is not as obvious as the first question. So can you explain us this?
Yes, I mean, it's challenging, but mainly it's on, the data on the use of these services can be useful to understand, let's say, which collectives of the society might be, let's say, more against using them. It's not only the data that we have shown of navigation and so on, but it's also important the user experience data, how people experience being in an automated vehicle, for example, and how are they safe. it's one thing it's if the vehicle is safe, and one thing if I feel I'm safe, because it's very two different things. So, and we need to understand, okay, the person with this culture maybe it's feeling unsafer than other persons. So I think that besides this navigation data, it's also important this perception of the users that are navigating in them. And also the other thing that I always thinking while let's say focusing on CCIM, it's also on the patterns of use. Let's say the example, I think it was of the borders, that the people take the car and then they want to substitute this with an automated vehicle so that people don't take the car. We need to understand what modes of transportation CCIM will replace, because if we think on Barcelona, and I'm taking the metro and now I'm taking a CCIM, are we improving something? I don't think so. So that's another thing we should think of.
Perfect, Alex. And in Diversify, have you analyzed this safety perception from a gender perspective between women and men? And the acceptability of SICAM solutions by men and women?
It's the idea, but we are not there yet. We are still in the data collection phase, and we are hope to finish it by this month. So we will do that.
Okay.
But it's true that the project has the focus on cultural, geographical, and policy diversities. So gender is a side thing to those three things, but for sure we will take it into account.
Okay, yeah. I remember that I was involved in the Diamond project that was addressing the acceptability of automated vehicles by gender, by women. And there were really differences between the acceptability level by women and by men. And the safety perception was one of the factors that created these differences.
Yes, we also had some preliminary data that was interesting, and is that we were comparing like what's using an automated car and what's using like an automated metro, for example. Mm-hmm. And there was a lot of difference between, like, say, things that go on rails and things that go on the road. Like trams, metros were quite accepted, but then when you go to cars, buses, then it's a different thing. It changes.
Okay, Andras, let's come back to you. I think that to go to main barriers to align the standardization of infrastructure data, you have mentioned these barriers, no? I think that we can give this as answered. Mm-hmm. Mainly barriers are to want to overcome the barriers, no? Because otherwise the barriers are human barriers, not technological, not scientific barriers, are human barriers.
We have a main human barrier that we don't have enough standardization experts working on these standards. So we are lacking young scientists contributing to this, and that could unlock this major barrier, and also that we are lacking a little bit of funding. There is no more European standardization mandates that happened. The last one on CITS ended up 10 years ago almost. And we have only very targeted standardization contribution work packages in European co-funded projects that are very specific to problems. And we need to get a much bigger knowledge of the complexity of this standardization work.
And Motere is your company.
Yes.
And what is Motere? Motere supporting this transition for a better standardization?
Well, actually, what we are doing is we are participating in a number of organizations. So we are members of the Hungarian Standardization Organization, MST, and we are delegated to a number of ISO SAN standardization technical committees, like for artificial intelligence, for big data, for intelligent transport systems, for geographic information, for IoT and digital twins.
So we are present there, but also we are contributing to SAE, IEEE. Also, I am coordinating Sensoris, the sensor interface specification, which is an industry standardization association standardizing in-vehicle perception data to be delivered to the infrastructure.
Do you have young people in your team?
Yes, I have a team. I have 5 employees
young
working
people
together. Yes, yes, younger than me.
Well, but I mean more younger.
Yes, indeed. I am the white bird.
Because as you are saying, we need young people to get this challenge for the future. Yeah. So nice to know that you have young people in your team, younger than you, even younger than me. Okay, Daria, lessons learned from ESERCOMD and ESRIUM projects, which are the 2 projects that you have been involved in. So what have you learned from these 2 projects?
So I think the main key learning is that while working collaboratively on achieving the same goals brings us much forward to the desired goal. We have a lot of people in the consortium with various expertises, and everybody brings very valuable points to the table. And I think when it comes to standardization, we can see, for example, in ASFINAG while working that we are not encountering any huge problems. And what I mean by that, since a lot of has been done in the sector and a lot of it has been doing, we have specialists within ASFINAG who are pursuing with the standardization efforts, and as well as a very strong consortium partner who are working on that. And I think this collaborative work that we see each other work, the ones who are developing the solution and the one who are trying to put the standards to it, is the crucial thing in that. This was for the standardization part, and I think for the other part about the infrastructure monitoring and prediction. Right now, with the systems that we have and with the solutions that we have, it foresees one car equipped with all of the technologies, cameras and sensors, and it will bring us within 4 years to desired destinations, because this is only one car that is driving through all of the highway network. And for example, if we would equip our highway maintenance authorities with such technologies with their own cars, it will bring us to the daily basis of the updated status, because they need to, every highway maintenance authorities, they need to monitor the area every day, but they are not equipped with this specific technologies. And for example, we are now in a testing phase of one of the solutions, such as developed with also within the ESERCOMD project through the partner Galileo research, and we equipped our cars with their technology, and we see that we have been doing, like just with 3 cars, more than 100 kilometers per day, collecting those data. So I think so. A lot of decisions need to be made in that regard, and I think that's why these, I think, 2 examples show that this collaboration and such projects really bring us as a community forward to what we want to achieve in the end.
Okay, so you have very clear the further developments in future initiatives. Perfect, Daria.
I am the one who gives you the dates. When can be it achieved? You already asked it. So I'm already asking before you. You're asking me.
Perfect. Okay, Jose, and the same for you. Lessons learned from when you were developing or involved in Zenbox, in the development of Zenbox digital platform. What are the lessons learned and the challenges that you have faced?
Mm-hmm. So, well, let's say we have, as I said earlier, we're in the process of going up to commercialization of the current platform that we have, although we are working on improving it from different perspectives. In this case, we come from the infrastructure side. Let's say we and especially in roads, it is traditionally quite less technology-driven and less developed than other sectors such as aerospace or vehicle manufacturing, etc. So this is, let's say, relatively a problem, but also an area of opportunity for, let's say, a further area of development. And in this context, we have found different, let's say, limitations on the, let's say, deployment of digital twins of our Zenbox digital twin as our in-house digital twin as a service to customers. The first one sometimes is related to user acceptance, because we need to communicate better the advantages of the technology that we provide and the opportunities that digital twins have and the different, let's say, end applications that we can develop. And also, well, there's certain limitation, let's say, from the financial side as well in its deployment. This is connected to this second point, which is related to costs. So let's say we need relatively large capital expenditure that then needs to be seen in a long-term period, not in a short-term period, which is not normally the case with public entities managing infrastructures.
Yeah, this maybe this is related with the business model that we were talking before. If this should be public, private, who put the money?
Yeah,
exactly. Who must put the money?
Exactly. So this is, let's say, one limitation that comes from the way in which the sector works. A third point, and also related to, let's say, being a sector that is not so much developed currently, technologically or historically, it's data availability and data quality. With respect to bridges, for instance, we use visual inspection. We still use visual inspection and qualitative analysis of the state of a bridge. In pavements, we are evolving. Projects like Estrium are evolving in, let's say, automatizing this, but we still use a lot of ground field data and expert knowledge data. And this has to be fused with IoT data and stuff. So we are taking our approach is to take a data fusion approach using IoT data, starting to use satellite data, and also, let's say, qualitative data that is most common in the sector.
Okay.
And the last one, I would say, is that we are working in mobility in the transport sector. So we have different use cases depending on, we work on railways, roadways, ports, inland waterways. And within these, there are many different types of assets, from locks to pavements to rails. And there are different use cases with different degradation patterns that adds a lot of complexity to having, let's say, a transport and mobility level digitization of infrastructure.
Okay, Jose, thanks so much. Let's go to the two last questions from my side. First for Eulalia, secondly for Alex. I have here highlighted one nice concept, fully digitalized infrastructure. Nice. What is your vision about fully digitalized infrastructure? What is missing to reach this nice concept?
I think we have not enough time to answer that.
Oh my God. Okay, use 1 minute as you want.
Okay. No, first of all, what we need, of course, it's we need to increase the performance of our network. Okay. We need to ensure that it's sustainable, that it's energy efficient, and that it's fully reliable. If we want to crowd our cities with sensors that needs to communicate vehicle to vehicle, vehicle to infrastructure, okay, this is a lot of energy behind that needs to be taken carefully. It's not something, it's not a silly thing. Put sensor, put energy, and that's all. No, okay, because if not, in 1 year we do not have light for energy for anyone. So this is something that needs to take into account. And then how to really distribute the processing, who needs to process everything on this infrastructure. So if we have, as it is said by David this morning, the edge computing, okay, we still need to do a lot of work on edge computing and ensure who is responsible of processing what and to communicate that information to whom, because I don't need to spam all the cars that are on on a city of an accident that happens maybe on just the border of the city, but need to ensure that the information achieve the target people, the correct target people, and maybe no one else. So I would say reliability, sustainability, and a good performance of the system. And who is going to do that? Orchestration. So we need to do a lot of work on orchestration.
And this is a nice argument to support the green energy generation. Otherwise, this is not sustainable.
And low energy sensors, yeah.
We need a green energy to sustain all these technological developments. We cannot go to carbon energy or hydraulic energy. We need green from sun energy or wind energy and things like this, no? I guess. Okay, thanks so much, Eulalia, for using this minute in a smart way. And Alex, data from infrastructure, coming back to this combination between infrastructure and behavior and use of the infrastructure. Okay, so how this data coming from infrastructure and the data coming or gathered from behaviors can be complemented each other to improve the inclusivity? How can you introduce the concept inclusivity in this data gathered from the infrastructures and combine this data with the behaviors of people on the road? How can you combine both and enhance the inclusivity? Alex, from your perspective.
Well, first of all, we need, let's say, precise data, which we are not yet there. And we need, I think, more integration of data. So nowadays, I think that there are different data providers in not only across countries, but within the same countries. You have different data providers. Each one provides its own data with its own format. So the integrating of this data is already a challenge. But then it's also about a bit what I was saying before. It's not on not only where we move, or yes, where we move, but also how we experience this move. And for example, in infrastructures, you could also include, let's say, a picture to these models. You could include pictures of the roads, of the streets. They are wide. They are not wide. Maybe I can go with a wheelchair, or maybe I cannot go with a wheelchair. So I think that this data on infrastructures is essential to understand how to include all types of people and contexts within transportation.
Can you give us an example, for example? One only example. One people in a wheelchair try to cross a road. There is a light. What can happen there?
Well, I was not thinking on that. I was thinking on, for example, in some streets of Barcelona, the sidewalk is like this. So if you have a wheelchair, you cannot go. Let's go.
But this is not related with SICAM.
No. Well,
I mean with SICAM applications.
You mean more into SICAM applications?
Exactly.
Well, I mean, SICAM is one very good option for persons with certain disabilities, for sure.
And we will need assistance, no? Remote assistance for these kind of situations.
That's one of the challenges. But the other thing is that if you think, I don't know, in public transportation, this person has to go to the public transportation stop, and SICAM maybe can offer this service, let's say, individually.
Well, through this remote assistance. We need to enhance this concept, remote assistance.
And on the other hand, that's the other, let's say, elephant in the room, that is that SICAM should be cheaper because we are not paying a driver. So this service should be more available to persons with limited income. We know how the world works, and when SICAM is all fully deployed, it probably won't be cheaper. But in principle, they should allow it.
More affordable for everybody. Yes. Nice reflection. Thanks so much, Alex. Thanks all. I don't know if anybody here in the room has any additional question or remark or highlight or last word. No? You are hungry now? I think so. A big applause to all the panelists, and thanks so much for being here.
Infrastructure itself.
So finally, thank you everyone for the very enriching discussions and also all the knowledge shared throughout this morning. And to close the first part of the day, we welcome back Ismael Colomina, who will offer final reflections and a look at what lies beyond the GAMS project.
Thank you again. I know that I am standing between you and lunch. I have only 40 slides to conclude, but maybe I will not use them. Now, to summarize GAMS, many thanks, Francesc, because you made the best summary, better than I did, and it is like in here, robots mapping for robots, and that's what I wanted to get across, and you did it very well. So this is as for GAMS. I am not able to summarize properly what you discussed. I believe that the main message here is that there's a big, huge field ahead of us with many challenges, many technologies, and today we've seen that you can approach them from many different perspectives. That's probably also one of the values of this workshop that I discovered. I still believe that, at least for some of my people, our young employees here, they still don't know what CCAM means. So maybe we'll tell you afterwards. I would like just to, tackle three let's say, items, ideas that cross my mind that I cannot stop myself or communicating them. One was this discussion we had about public bodies, private bodies, standardization, and so on. The traditional business model of mapping of the US was a failure, total failure, because the European maps are excellent. The Swiss maps, the German maps, let me make a bit proud of myself. The Catalan maps, they're excellent maps. Excellent maps. Nothing to compare with the US. However, while the different public bodies were fighting against each other in Europe, and finally they got that inspired big victory after many discussions. In the meantime, an American company, Google, came with its maps. And which maps are we using today? The Google Maps. We should learn the lessons. This cannot happen again. That's one thing I wanted to mention before lunch. Technology challenges. We must be aware, at least in terms of positioning, that technology is making a lot of progress. I can recall 40 or 30 years ago, when we were trying to introduce GPS at the time, everybody was against that. This will not work. We wanted to have GPS in airplanes to facilitate, speed up the map making. This will not work, never work. You know where we are. Now, without GNSS, we are not able to do any maps. The same thing happened with drones. We started working with drones in 2004, and we went to some European agencies, and the problem was that nobody was believing that. Drones will never fly, said once to me an European officer. We should learn the lessons from that. And and I don't know what's going on with now automatic driving. Also, I had discussions and asking questions to Selim, comparing what's going on in the US and what's going on here. So this is what about technology I wanted to say now. I talk about GNSS and how it changed the way we do things radically. Now, today, we have a new generation of radio navigation satellites being investigated. Those are the LEO PNTs, so low Earth orbiting GNSS satellites with signals that can potentially penetrate buildings, and solve many of the problems we have. So this may change radically the way we approach our problems. We have also quantum technology applied to navigation, and those sensors have very, very, very small errors. This can also radically change the way we do things. And there are also people, organizations investigating the miniaturization of such devices. So these technology changes, or these new technologies might radically change the way we approach the challenges we have. And last not least, you mentioned, I believe it was Andras who said it, about the problem of not having young people being attracted by this, maybe because of low wages, maybe because of uncertain scientific careers. We must be aware, and I take the opportunity to bring this up, that we all depend on a very weak infrastructure, which is GNSS. If we lose the satellites, we might lose, you know it, now it's very well known, bank transfers, energy, internet, mobile communications. But this infrastructure, in turn, is depending on an even weaker infrastructure, labs kept by astronomical observatories, by universities, and these organizations are underfunded, understaffed, and this is a very risky, difficult situation. And we must be aware that if we do not keep and take care of this level, the universities, the labs, the young people, we are, putting all of the rest of our infrastructure at stake. That's for me a very important point that I would like to make today. And all this said, it's lunchtime. This morning I thought I had everything under control, but I didn't. I forgot about the Hungarian language. So my apologies. So with this, I believe it's time to finish this meeting. Muchas gracias. Muchas gracias. Obrigado. Merci beaucoup. Vielen Dank. Many thanks.